first question. First question is limit x tends to -1. Limit x tends to -1, and the equation given is x to the power 10 plus x to the power 5 plus 1 by x minus 1. So in this question, it is given that limit x tends to -1, and the equation is x to the power 10 plus x to the power 6 is -1. So simply we will put the value of x, that is -1, in this equation, and we will get the answer. -1 to the power 10 plus -1 to the power, this step, and this is very important step. This step carries half marks. As we know, 1 by 0 is infinite, so 1 by infinite is 0. So 1 by infinite is equal to 1 by x, so 1 by x equals to 0. So 1 by 1x tends to 0. So now we will put the value of 1 by x, which is we'll do that the highest power of this equation will divide the numerator and denominator by the highest power. So in this question, the highest power is x to the power 4. So we'll divide numerator and denominator both by x to the power 4. x to the power 4 minus 5x plus 2 by x to the power 4 whole divided by x cube minus 3x plus 1 whole divided by x to the power 4. So now we'll divide both numerator and denominator by x to the power 4. Limit x tends to infinite. X to the power 4 by x to the power 4 is 1 minus 5 by x cube plus 2 by x to the power 4 whole divided by x cube by x4 is 1 by x minus 3 by x cube plus 1 by x to the power 4. So we have converted this equation to 1 by x form. Now we'll convert this to 1 by x. One minus 5 by x cube plus 2 by x to the power 4 by 1 by x minus 3 by x cube plus 1 by x to the power 4. Now inside the box we'll write x tends to infinite, so 1 by x tends to 1 by infinite, so 1 by x tends to 0. So this is a step. Now we'll put the value of 1 by x, which is 0, in this equation. One minus 5 into 0 cube plus 2 into 0 to the power 4 by 0 minus 3 into 0 cube plus 0 goes to 1 by 0, which is infinite. So next question also we got the answer. So I'll proceed to the next question. Next we will practice only this much questions of limit. We have practiced 4 questions. Prove from normal limit x tends to -1 and limit x tends to 0. The next 2 we have practiced of limit x tends to infinite. The next chapter we will move to linear inequalities. From here also we will practice 2 questions. So this is the 5th question of our class. 2x minus 1 by 3 greater than equal to 3x minus 2 by 4 minus 2 minus x by 5. So linear inequalities in this question, where we have whole multiplied by 5 minus 2 minus x whole multiplied by 4. As we have taken the LCM as 20, so 4 will be multiplied to the 2 minus x and 5 will multiply to 3x minus 2. So the next step is 2x minus 1 by 3 greater than equal to 5 into 3x is 15x minus 10 minus 8 minus 4x by 20. Next, 2x minus 1 by 3 greater than equal to 15x minus 10 minus 8 plus 4x by 20. Now we will do cross multiplication. 3 will be multiplied to 15x minus 10 minus 8 plus 4x, and 20 will be multiplied to 2x minus 1. So 15x plus 4x is 19x. 10 minus 8 is minus 18. So 20 into 2x, 40x minus 20 greater than equal to 19 3 is 57x minus 54. So we'll do the next step here, which is the 40x will bring this side and the number this side, minus 20 plus 54 greater than equal to 57x minus 40x, implies that 34 greater than equal to 17x, implies that if we'll bring 17x this side, 17x less than equal to 34, which is implies that x less than equal to 2, means therefore the set of x will be, as x is less than 2, less than equal to 2, 0 1 dot 0 1 2. So this is a bit lengthy question. These questions also carry 2 marks, minimum 2 marks. So we'll move to the next question of linear inequalities. So the next question. So next question is solving both sides. This is very important question, and this question also may carry 2 to 3 marks in exams. This is the last question of inequalities. Then we'll move to very important chapter, derivatives or differentiation. This is the 6th question of our class. Seven less than equal to 3x plus 11 by 2 less than equal to 11. So here the less than equal to is given both sides, so we'll solve 7 less than equal to 3x plus 11 by 2, then we'll solve 3x plus 11 by 2 less than equal to 11. So we'll put a straight line and both sides will solve both equation. 7 less than equal to 3x plus 11 by 2. This side we will write 3x plus 11 by 2 less than equal to 11. First we'll solve this side. We'll multiply, it is 14 less than equal to 3x plus 11. 3 less than equal to 3x implies that 3x greater than equal to 3, x greater than equal to 1. So the set will be x equal to 1, 2, up to infinite. So left side we have solved. Next we'll solve the right side. 3x plus 11 less than equal to 22. 3x less than equal to 11, x equals to 11 by 3. So this question is also over. Next, the linear inequalities part is over. We'll move one of the most important chapter of class 12, that is derivation. First question of derivation we'll do. This is the 7th question of our class. E to the power sine t. So first we have to derive this equation. We'll say let y equals to e to the power sine t. Then what we have to find? To find dy by dx. We will find dy by dx. So implies that dy by dx equals to d is to the e to the power sine t with respect to d sine t to d sine t by dt. Implies that dy by dx equals to the derivation of e to the power x, e to the power any power is the same, means e to the power x, derivation of e to the power x is e to the power x, and here derivation of e to the power sine t is e to the power sine t. So here we write equal to e to the power sine t into the derivation of sine t is cos t, implies that dy by dx equals to cos t into e to the power sine t. This is the answer. So basically derivation chapter is very easy, just we have to remember the formulas of derivation. So first question we have completed. We'll move to the next question. Next question is, this is the 8th question. Root over of x square plus bx plus c let y equals to root over of ax square plus bx plus c. So in derivation chapter, every equation will take it as y, then we will find the derivative of it. So let y equals to root over of x square plus bx plus c, then we will write to find dy by dx. Implies that dy by dx equals to d root over of x square plus bx plus c by d x square plus bx plus c into d x square plus bx plus c by dx. So first we'll find the derivative of this root part, then the part without root. Dy by dx equals to 1 by 2 root ax square plus bx plus c, as root over of derivation of root x is 1 by 2 root x, so derivation of any root part is 1 by 2 root over of that equation into, first we'll find the derivation of ax square plus the derivation of bx, then the derivation of c. Here c is constant. The derivation of ax square is 2ax, because the derivation of x square is 2x, and the derivation of ax square will be like that, 2ax plus derivation of bx is b plus c constant. The derivation of any constant is 0, so plus 0 implies that dy by dx equals to 2ax plus b by 2 root over of ax square plus bx plus c. So this is the final answer which we get. So simply derivative questions come minimum 2 marks. The minimum weightage of derivative questions are 2 marks. So this answer also we get as 2x plus b divided by 2 root over of x square plus bx plus c. We'll move to the next question. Next we'll move to the next question, 9th question, that is root over of tan 3z. Root over of tan 3z. In derivative also, trigonometric function also have their own derivatives formulas. So this question we will also find very easily. So let's do it. So first step, let y equals to root over of tan 3z to find dy by dx, implies that dy by dx equals to d root tan 3z by d tan 3z into d tan 3z by d 3z into d 3z by dz. So this question we have derived that d root over of tan 3z by d tan 3z into d tan 3z by d 3z into d 3z by dz. dy by dx equals to 1 by 2 root over of tan 3z into the derivative, as I have said, the derivative of any root function is 1 by 2 into root of that function. Then derivative of tan 3z, the derivative of tan x is sec square x. The derivative of tan x is sec square x. So 1 by 2 root tan 3z into sec square 3z into derivative of 3z is 3. So our final step, dy by dx equals to 3 sec square 3z by 2 root over of tan 3z. So here we got our final answer. So final answer we got is 3 sec square 3z by 2 root over of tan 3z. So we will move to the next question. The next question is a to the power ln x. This is our 10th question. First step is let y equals to a to the power ln x. To find dy by dx implies that dy by dx equals to d a to the power ln x by d ln x into d ln x by dx. In this question we'll learn two more formulas, one of a to the power x and another is ln x. So these are two different functions. Let's see what will the answer of this question. dy by dx equals to, the formula of a to the power x is a to the power x into ln a. So here we will write a to the power ln x because the value of x here is ln x. A to the power ln x into ln a into derivative of ln x is 1 by x. Implies that dy by dx equals to a to the power ln x into dot ln a into 1 by x. So this is the resulting answer. This is very simple question. This question will not carry more than 2 marks. So the resulting answer we got that a to the power ln x into ln a into 1 by x. So next we will proceed to the next question. Now up to we have completed 10 questions. More 3 to 4 questions will solve total in this class. From derivative more 2 questions at least we will do now. Eleventh question is x to the power sin x. This will solve in a different way because this function carries the formula of x to the power x, in which we have to take both side ln, then we will solve it. This is a lengthy question. This questions carry 3 marks. Let y equals to x to the power sin x. So then taking ln in both sides means in y side also will take ln and both RHS and LHS side will take ln, means implies that ln y equals to ln x to the power sin x. Implies that ln y equals to sin x into ln x. Now we have to find the derivative of ln y and sin x into ln x to find the value of dy by dx. So here we will write differentiating both sides implies that d ln y by dy into dy by dx equals to sin x d ln x by dx plus here we will put the product rule. Product rule says that if the first function is fx and the second function is gx, then the derivative of fx into gx is fx d by dx of gx plus gx d by dx of fx. Means first we will take the fx outside, then we will find the derivative of gx. In the second part we will find the derivative of fx and we will take the gx outside. So plus ln x d sin x by dx. Derivative of ln y is 1 by y into dy by dx equals to sin x into 1 by x plus ln x into cos x implies that dy by dx equals to y whole into, we'll take LCM as x, sin x plus 1, sin x plus 1 plus x ln x plus, x ln x cos x implies that dy by dx equals to, now we'll put here the y's value what we have taken before, that is x to the power sin x, x to the power sin x, x to the sin x minus 1 into sin x plus sin x plus x ln x cos x. Here I have taken minus 1 power because this denominator was x, here also base was x, so here I have done x to the power sin x minus 1 multiplied by sin x plus x ln x into cos x. So this is the final answer. So these questions will carry minimum of 3 marks in this question, and this x to the power type of questions, x to the power x type of questions are very important. We'll move to the next question. The 12th question, that is root over of sec two x plus 1. Root over of sec 2x plus 1. So here we'll we'll learn another derivative of another trigonometric function, that is sec x. Let y equals to root over of sec 2x plus 1, then to find dy by dx implies that dy by dx equals to d root over of sec 2x plus 1 2x plus 1 by d sec 2x plus 1 into d sec 2x plus 1 by d 2x plus 1 into d 2x plus 1 by dx. So here we have differentiated by d root over of sec 2x plus 1 with respect to d sec 2x plus 1 into d sec 2x plus 1 with respect to d 2x plus 1 into d 2x plus 1 with respect to dx. So next step will be dy by dx equals to 1 by 2 root sec 2x plus 1, and the derivative of sec x is sec x into tan x sec 2x plus 1 into tan 2x plus 1 into derivative of 2x is 2 and derivative of 1 is 0, as this is 1 is a constant, so derivative of 1 is 0. So the numerator part is dy by dx equals to 2 sec 2x plus 1 into tan 2x plus 1 by 2 root over of sec 2x plus 1. So here we can cancel 2 by 2, 2 and 2 will be cancelled. And the another important step, this is not the final answer, we have simplified, but we'll simplify more. We'll convert this root part to, we'll rationalize this root part, means we'll simply rationalize the denominator, means we'll multiply this to both numerator and denominator. Root over of sec 2x plus 1 by root over of sec 2x plus 1. dy by dx equals to, this will multiply sec 2x plus 1 into tan 2x plus 1 into root over of sec 2x plus 1 whole divided by this root sec 2x plus 1 into root sec 2x plus 1. This root will be cancelled, so it will be sec 2x plus 1 and sec 2x plus 1 and sec 2x plus 1 will be cancelled. So the final answer is tan 2x plus 1 into sec 2x plus root over of sec 2x plus 1. This is the final answer. This question will also carries 2 marks, as this is a very lengthy question. Then we will move to the last question of derivative question, last derivative question. Then we'll move to LPP. 1 or 2 questions we'll do from LPP chapter. This is our 13th question, I guess. Root over of sine root x, let y equals to root over of, this question carries of 2 marks only. This is a simple question. These are the steps basically to write let y equals to the function and to find dy by dx. These are the basic steps we have to write it. D root over of sine root x by d sine root x into d sine root x by d root x into d root x by dx. And so the I have differentiated that d is root over of sine root x with respect to d sine root x, then into d sine root x with respect to d root x into d root x with respect to dx. It will be 1 by 2 root sine root x into sine root x, means sine root x will be cos root x, as the derivative of sine is cos, into root x is 1 by 2 root x. Cos root x by 2 sine root x into 2 root x implies that dy by dx equals to cos root x by 4 root x and into root over of sine root x. This is the answer. So this was very simple but little lengthy, but this was very simple question. This question will only carry 2 marks. So the resulting answer was cos root x by 4 root x into sine root x, root over of sine root x. Now we have completed all the questions of derivative. Yes. From LPP, we will do only one question. Then 2 to 3 questions I will give homework. One from LPP, 2 from derivatives, and another from limits. So this will be going to be the last question of our class. After this, I will give 2 to 3 questions homework. You will solve this and comment the answer below. So the answer, write the answer in the comment. So the LPP question is optimize z equals to 5x1 plus 25x2 subject to x1 plus x2 less than equal to 1, then x1 then minus x1 plus 5x2 greater than equal to 5, and here x1 comma x2 greater than 0, greater than equal to 0. So this is the question. Here it is given to optimize. In LPP some questions are given to maximize or minimize. Optimize means we have to find both the maximum and minimum. And first we'll write the step 1. This question, LPP questions will come the 5 mark questions because we have to draw the graph here. So LPP questions are very important questions in class 12. So we'll do the step 1. This carries of 4 steps. First step, we'll convert inequation to equation. Converting inequation to equation. First x1 plus x2 equals to 1, which is equation 1. Next is minus x1 plus 5x2 equal to 5, which is equation 2. We have converted inequation to equation. The next we will the step 2 will do this side, because the graph we have to also do the graph. For this side we will leave it for graph. The step 2 will do that side. Step 2, draw solution table. For equation 1 and 2 we will draw solution table. This is for equation 1. The solution table will be for equation 1. If x1 will be 0, then x2 will be 1, and if x2 will be 0, then x1 will be 1. So this solution table is for equation 1. Then for equation 2, this for equation 2, minus 5 0 0 1. This is for equation 2. Here we will do the step 3, which is the graph part. This is the very important part of this question. x1, x1 dash, x2, x2 dash. This is our origin O. 1 2 3 4 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1 2 3 4 5, minus 1, minus 2, minus 3, minus 4, minus 5. So this is the graph. Here we will write in both x1 and x2 axis 10 small division equal to 1, 10 small division equals to 1 unit. So this is the graph, but now we'll put the value, we'll find out the points in this graph, and we'll draw the line. First, for the equation 1, 0, 1. 0, 1 is here. Next is 1, 0 is here. So here we'll draw a line. This is for equation 1. Then it is for equation 1, it is given less than equal to. So for less than equal to, we'll put a downward arrow. Then next one is minus 5, 0. Minus 5, 0 is this one, and 0 minus 0 1 is also this one. So we'll draw a line. So this is equation 2, which is given that this is the line for equation 2 in which the points are minus 5, 0 and 0, 1. So this is the line, and in equation 2 it was given greater than equal to, means here we can put an upward arrow. So the feasible reason here will be, the question here was greater than equal to, sorry. So greater than equal to, here we will put the upward arrow. So here the feasible reason will be this one, means this is a unbounded. This point will take as A. So here we will write the required feasible reason is unbounded. This point is A and this point is B. Yes, this point is B. So here we have to write the required feasible reason is unbounded, as this is an unbounded graph. So next we have to find the step 4, the last step. This is A, this is B. So this is A and B, the points. Here we will write Z equal to the value of the equation of Z, 5x1 plus 25x2, 5x1 plus 25x2. Here simply we will put the value 0 plus 25 equals to 25 and 0 plus 50 equals to 50. So here it is, space is there. We will write the final step. This is the therefore question. So we will write Z optimum equals Z optimum is in which Z max equals to 50 at B 0, 2 and z minimum equals to 25 at a 0 comma 1. So this whole question, first the question is the given part, then step 1, step 2, step 3, the graph 1, the most important one, step 4, then the last therefore one. This whole comprise of 5-mark question. So today's class all topics are covered, means all questions are covered. Now I will give some questions for homework, then we will wind up this class. Questions to practice. First question, I will give one from LPP. Maximize z equals to 5x1 plus 6x2 subject to 2x1 plus 3x2 less than equals to 6 and x1 comma x2 greater than equal to 0. This homework question is for LPP. Next, from derivative, log x to the power tan x. Here we will put the formula of x to the power x, means we will take ln both sides then solve it. Next question, one more question from LPP. Yes, ln root x plus 1. The next question I will give from linear inequalities. Minus 5 less than equal to 5 minus 3x by 2 less than equals to 8. In this question we will solve the both side of equations. Then the last question from limits, and that will be for infinite one. Limit x tends to infinite x to the power 3 x to the power 3 plus 2x square plus 3 by x to the power 4 minus 3x square plus 1. So this one, these are the last 5 questions. These 5 questions is for homework. One is for LPP, 2 are from derivatives, and one is for from linear inequalities, and one is for from limits chapter. So this is all for today's class. We have practiced very important questions from the four chapters: limits, derivatives, inequalities, and LPP. So these are the homework. Solve these questions and write the answer in the comment. So for today's class, this much. So thank you.